Let's talk about finding mass. By integration. And for this part, you have to know the concept of density. So let me ask, what is density?
Oh, mass over volume.
Yeah. Usually people write it as rho for density, m for mass, v for volume. However, that's for like three-dimensional objects. Sometimes you might have an object that's very flat and thin, where the volume is close to zero. And rather than talking about mass per volume, it makes more sense to talk about mass per area, because it's like it's flat everywhere. So that has a name, that's called the surface density. Which is mass divided by area. And people use mu for surface density. But I guess the ones that are more practical is linear density. And this is for one-dimensional objects like wires. If you have a wire, and if it's a heavy wire, you would have bigger density, right?
Linear density is number of atoms over the area that's being used.
No, that's not right.
Well, that's material size.
Okay, well, that's not right. So linear density is like when you go to buy a set of wires, and depending on how heavy it is, it might give you something like pounds per foot. Like if you take a foot of this wire, it will weigh like 0.2 pounds or something like that, right? Mm-hmm. And if you think about the pounds, that's weight, that's the mass, not the weight, it's the mass, and then foot is the length. You're dividing the mass by the length, that's called linear density, right? So linear density will be mass over length. And the usual letter people use for linear density is lambda. And lambda is equal to mass divided by length. So in your physics textbooks, this will be mostly what you see in the density. And then I've seen this one also. This is rarely used, I guess. It's less practical because you don't have that many flat objects. Ideally, we should do a lot of problems with this one because this is the most practical one. But many problems that you would write here can only be solved by doing multivariable calculus, which is outside the scope of this class. So I will mainly stick with these two, okay, and only some specific types of this. Okay. So here's our first question. Suppose a wire is given by y equals to x squared and x from 0 to 1 with linear density lambda equals to 4x. Find its mass. Now what does this mean? Well, it's a part of the parabola from 0, 0 until 1, 1. And judging from this formula for the linear density, it's not a uniform object. See, when x is 0, which means you're over here, the density is 0, which means there's like almost nothing. So it's like a wire that kind of tapers off. It's like gets thinner and thinner as you go this way. It becomes almost nothing. As you go over here, it gets thicker and thicker, and it becomes heavier, so that the density over here is 4. So it goes from 0 to 4. In that case, what is the mass of that wire? That's the question. Okay, solution. We want to find mass m, right? What's the universal formula?
Density.
No. What's our universal formula for finding anything?
Oh, the sum.
Oh, the sum.
Sum of its parts. Okay. And then you have to think about what this small dm means, right? You're chopping this off into many infinitely small pieces, and you're adding them back up again to get the entire thing, right? So what does that mean?
The derivative.
No, it's not very good. You're dividing this into small bits, right? Just like that. And the mass of these small bits is what we call dm. Now if you zoom this and draw it, it's more like a straight line here. Okay? And you can think about dx, dy, ds. But that doesn't really tell us the mass. We have to use the density somehow, okay? So can you think about the expression for dm? What's the mass of this thin part? How do you get it?
Square root of dy dx.
No, okay, so ds is square root of dx squared plus dy squared. But that gives you the length, right? It doesn't give you the mass. To get the mass, what do we do?
You need to find the volume.
No, there's no volume here because it's a linear density. The density we're talking about is linear density.
Well, if we find the length and we have the lambda, then we would just times the lambda times the length.
Yes, that's exactly what you do, right? What is mass if you have linear density? Mass is lambda times length, right? So you have lambda times ds. So that's what you put here.
Oh.
Lambda times ds. But what is ds? That's square root of dx squared, dy squared, right? And then what should you do? You can't integrate this, so what do you do? What's the trick?
Set it to dx or dy.
Okay, you choose dx or dy, but how? How do you make this dx appear?
You would share the log for dx.
No, that's the second part.
Oh, you're gonna say you're integrating in terms of dx, so isn't that where it comes from, the dx?
Can you just put dx here and set this to equal? These two equal?
Yeah.
No, these are not the same.
Lambda is equal to 4x. And you just plugged it in.
That's what I did, but is this same as this?
No, because it's dx.
There's an extra dx, so they're not the same.
Right.
So how do you make it equal?
Put it on
You
the
would
fifth.
divide everything by dx.
Yeah, you divide by dx and then multiply by dx,
And
okay?
then share the log.
Yeah. And then you do the other parts, okay? So after putting the dx in and doing like setting the fraction apart, and by the way, x goes from 0 to 1, right? So 4x square root of 1 plus dy over dx squared dx, just like before. And because dy over dx is what? What is dy over dx?
That's
The
y
derivative
equals to x squared.
is 2x.
I have a question. Is this where, when one of the cases where you're saying that when we do the integration, something pops out that cancels?
Right, so if this was length of that wire, if that was the question,
We wouldn't be able
we
to
wouldn't
do
be
it.
able to do it, right? But somehow this is there, now you can do it. Yes?
Why did you put 2x and it's x squared? Y is
dy dx is what? What does dy dx mean?
derivative.
What's the derivative of x squared?
It's an x, 2x.
Yeah, 2x.
Oh.
2x is the derivative, right?
2x,
So that's what replaces dy over dx. Okay. And you want to say u is equal to square root of 1 plus 4x squared. U squared is 1 plus 4x squared. And you differentiate both sides. So if you differentiate u squared, what happens? 2u du. If you differentiate the right side, you get 8x dx divided by 8x. And this reduces, so you get u over 4x du equals to dx. And that's going to cancel, right? So you end up with, oh, and by the way, when you plug in 0, you get 1, u as 1. When you plug in 1, you get square root of 5 as the value of u. And then you have 4x. We decide to call this as u. dx is u over 4x du. And these cancel, right? And you're integrating u squared, which gives you 1/3 u cubed.
Yep.
And you plug in square root of 5 and 1. So it's 1/3 square root of 5 cubed minus 1. So that's the mass of the wire.